A split second, the Big Bang, and the whole universe was born.
In the blink of an eye, literally, so much can happen that it would blow your mind.
How did we get here? And what is the universe made of?
The secret of creation, the secret of everything is locked in that first second.
Technology stands on the brink of revealing the Big Bang Theory. Scientists believe that in the first second after the Big Bang, the building blocks were created for every star and planet in the cosmos.
What we've learned is that more can happen in a fraction of a second, in a blink of an eye, than you can imagine.
In the beginning, there is nothing. No matter, no energy, not even empty space, because space itself doesn't exist. No time passes, because there's no such thing as time.
If we want to really understand our place in the universe, we have to go back to the very beginning and understand how it all came together.
Looking back to the instant of creation is a new idea. The theory of the Big Bang is widely accepted, but the concept is less than a century old.
But one of the things we have to put in perspective is how recent our understanding of the universe is. 80 years ago, the conventional wisdom in science was that the universe was static and eternal, had been around forever.
But this changes in 1929. At California's Mount Wilson Observatory, Edwin Hubble studies the light from galaxies. He observes that the farther the galaxy, the longer the wavelength of light it emits. Light waves stretch the more they travel, and stretching changes their wavelength. Something similar happens with light waves. If a galaxy is moving away from us, its light waves stretch, becoming longer and redder. It's called red shifting.
When we look at visible light, there's red at one end of the spectrum and blue at the other. Red radiation is the long wavelength radiation of visible light, whereas blue radiation is the short wavelengths. And as we look at the universe, we see the radiation from distant stars literally stretching so that the light gets redder. And the farther away we look, the redder the light is.
Galaxies around us have shifted to this red light. Galaxies around us have shifted to this red light.
We look out in all directions at distant galaxies, they're all moving away from us.
Nearly all galaxies are receding at 1,000,000 miles an hour. If galaxies are speeding away from each other, at some point, they must have all been together. The universe is expanding outward from a single point. It's the first evidence that the universe had a beginning. Hubble's findings lead to a radical concept: the Big Bang Theory. Out of the fireball, the four fundamental forces of nature form. Those forces underpin everything around us. Gravity is the reason stars and planets form. It rules the moon and tides and keeps us on the ground. Electromagnetism lights our cities, connects our phones, and runs our computers. And the two nuclear forces, strong and weak, bind the particles that make up our bodies and power the furnace of our sun. We're here because in the first second after the Big Bang, the four forces are created. Without them, the universe would be a featureless fog of radiation.
As we look out in space, we look back in time. Light travels at a finite speed. So the light we see from the sun takes about 8 minutes to get here. We see the sun not as it is, but as it was 8 minutes ago. We look out the night sky, we see the nearby stars. they might be 10 or 20 light years away. We see them as they were 10 or 20 years ago.
In the 1960s, at the Bell Telephone Laboratories, Arno Penzias and Robert Wilson are measuring radio waves from clouds of gas in the Milky Way. But the horn antenna they're using picks up constant interference. It sounds like this, and it's coming from every direction.
Everywhere they looked, they saw the same background signal. Didn't make sense to them. They first thought it was something wrong with their experiment. They cleaned their experiment. They removed the pigeon droppings in their experiment. That was a potential source of problems. They recalibrated their experiment. It was a very careful effort.
The strange noise remains. Penzias and Wilson home in on the source.
They were able to show that this radiation wasn't something on Earth. It wasn't something from our galaxy. It was something coming from deep space. It was everywhere.
The radiation hitting their antenna is older and farther than anything ever detected. By chance, they meet scientists at Princeton University looking for the aftershocks of the Big Bang itself. They now realize they are hearing an echo from the dawn of time. The Big Bang was so powerful and so hot, remnants of that heat still survive. The heat began as super-hot X-ray radiation. As it stretched and cooled, it became visible light, shifting from blue to red, then becoming microwaves, and finally radio waves. This faint radiation shines down on Earth all the time. It's called Cosmic Microwave Background Radiation, or CMB.
The cosmic microwave background is the echo of creation itself. It's the embers, the afterglow of the original shock wave that created the universe. If we had microwave eyes that could see microwave radiation, then every night we would see the Big Bang coming out. Looking at the heavens, we would actually see an explosion.
More than 13 billion years later, we have a way to see this cosmic glow with the naked eye.
You take your TV set, switch it between channels. A couple percent of the static that you see on your TV screen is radiation from the Big Bang.
This cosmic radiation is a direct connection to the Big Bang. It also reveals the universe entered a new phase, less than a trillionth of a second after its creation. Cosmic radiation is the key to discovering what happens next. A few beats of